Okay, the product of powers property, and I still didn't fix this slide. So product of powers property, not property. The product of two powers with the same base equals the base raised to the sum of the exponents. Let's break this down. Let's understand what we're talking about. So product means the answer to a multiplication problem of two powers with the same base. That is an example right here. We have the same base 6, and it has two powers, a 7 and a 4. Okay, so two powers with the same base. So two exponents with the same bottom number. That is equal to that base, that number 6 in this case, raised to the sum of the exponents. So adding the exponents. That is what we're looking at for this problem. So let's understand what's going on here. We have 6 raised to the 7th power times 6 raised to the 4th power. That, according to this information, is 6 to the 7 plus 4th power. So we can rewrite this as 6 to the 11th power. Let's understand this completely. This number, this 6 to the 7th, we can write this as 6 times 6 times 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6, 7. And this other number right here, we can write it as 6 times 6 times 6 times 6. And these are all multiplying each other. So we have how many 6s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 6s. 6 to the 11th. As you can see, we got the same answer. So let's go on to our next problem. Let's go on to a couple of practice problems. We have 7 to the 8th power times 7 to the 4th power. So if we're following this rule, we can say we can rewrite this as saying 7 8 times. We can do 7 times 7 times 7 and do that 8 times. And then multiply all that by 7 4 times. I don't want to write all that out, so I'm going to use this shortcut of saying I have 7 to the 8 plus 4 power, which is equal to 7 to the 12th power. Now if you wrote that all out, we have 8 sevens plus 4 sevens. That means we have a total of 12 sevens. It all works out. Let's do this next problem. We have m times n to the negative 4th times m to the 4th. I underline these with the same base number so that way I could see them better. I'm going to rewrite them now, because we know with the commutative property we can move things around in a multiplication situation to make them make more sense. So I have m times m to the 4th times n to the negative 4th. So this m times m to the 4th, that's essentially saying 5 m's altogether, so I can rewrite this as m to the 5th. And this n to the negative 4th, we can write that as 1 over n to the 4th power. If you don't understand why you can do that, I suggest watching the 7.1 video that I have already made. So when all is said and done, we can rewrite this as m to the 5th power over n to the 4th power. Last problem. This is the one that's tricky. So we have this last problem. We have 3 to the negative 3. Oops, I don't want to start writing yet. We have 3 to the negative 3 times 5 to the 8th times 3 to the 4th times 5 to the 2nd. So I'm going to rewrite this now with all these exponents in the same place. So we have 3, not to the negative 2nd. We have 3 to the negative 3rd power times 3 to the 4th power times 5 to the 8th power times 5 to the 2nd power. Now, following our rule from before, we can rewrite this as 3 times the negative 3 plus 4 times 5 to the 8th plus 2. So 3 to the negative 3 plus 4, negative 3 plus 4, that equals 1. So we have 3 to the 1st power times 8 plus 2 equals 10, 5 to the 10th power. Final answer. And that's how we do the products of powers property. Hope you enjoy.